Hi guys, my name is Mr. Leshin and I welcome you back to class. I hope you've been keeping safe. But I believe by the grace of God, we'll be back to class as soon as possible. Without wasting much of our time, I would like to take us to this week's topic, which is we'll be talking about electricity. We're looking at the concept of electricity, the electric currents, the circuits, potential difference, and electromotive force. This is the concept of what? Electricity. I would like us to look at the learning objective, what we've been set aside to achieve today, what we'll be looking at in electricity. The learning objective. At the end of this class, students should be able to explain electric currents, potential difference, electromotive force, state Ohms law, state and explain factors affecting electrical resistance, differentiate between resistivity and conductivity. These are what we will be looking at in the concept of electricity. I would like to tell you that concept electricity is the flow of electric current. The flow of electric, what we mean by flow, the passage of electric current, be it in a circle, in a circuit. So the flow of electric current. So first, we'll take the electric current. What is the electric current? This is the rate of flow of electric charge along a conductor. We all know what a conductor is. A conductor is any material that allows the passage of charge, that allows the flow of what? Charge. The opposite of conductor is insulator. It doesn't allow the flow of charge. It doesn't allow the flow of charge. So by definition, the rate of electric charge along a conductor. And the unit of electric current is given as ampere. Ampere, denoted as capital letter A. So mathematically, electric current is given as a quantity of charge over time, where Q is the quantity of charge and T is the time measured in seconds. Let me take you through the diagram to explain further on electric current. Look at this. Look at the flow of electric current going from the positive to the negative, and look at the flow going around what? The circuit. This is the battery. This is the conducting wire, the conductor that allows the flow of what? Electric current. Because it's a closed circuit now, it's given a light. Look at the filament light. The flow of what? Electric current. And electric current is the rate of flow of electric charge in a circuit. Yeah, so go back to the definition. The rate of flow of electric charge in a circuit. And mathematically is denoted as what? Electric charge, quantity of charge over time. Quantity of charge is represented as Q, which is measured in what? Coulombs. Coulombs. And T is the time, measured in what? Seconds. T is measured in what? Seconds. Let us look at the next thing. We have electric circuits. Electric circuits. Look at this. This is the circuit here in the diagram. This is the circuits. The diagram shows the electric what? Circuits, where they are with the room by which electric charges move. They are electric what? Circuits. That is the electric circuit there, and it's defined as the path provided, the medium provided for the flow of what? Current. And it is made up of what? A key, a battery, and a conductor. It is made up of what? A key, a battery, and a conductor. We all know what conductor is. It allows the flow of electric charge. The battery produces the what? The current. While the key is either open or it controls, like a control switch. That is what we call the key. We all have control switch in our house, whereby you to on the light, you press the control switch. To off the light, you press the control switch. So that is the key. So there are two types of electric circuits. We have the open circuit and the closed circuit. The major difference between this open circuit and the closed circuit is that the open circuit, the key is opened, which doesn't allow a complete flow of electrical current. It doesn't allow the flow of electric current in a complete manner. It breaks. That is, if there's a flow of current from the source, it won't get to where it produces light or discharge of filament, because there's a break in what? The conducting part. There's a break in conducting part. While closed circuit is a complete circuit. If the current should move from one point, it's going to get to the other end of the what? Battery. A complete flow of electric current. Let me show you the diagram. Look at this. This is an open circuit. Look at the open circuit and look at the closed circuit. The open circuit is not producing light. Why the closed circuit is producing light? Because the switch, the key is open. This is the key here. It's open. It's not contacting with the other terminal. It's not contacting with the other terminal. So this is the key is open. That's why we call it open circuit. When there's a break in conducting part, while this is the closed circuit, there's no break in conducting part. It allows the complete flow of what? Electric current. Take a look at the definition again. Open circuit, this is a circuit in which there is an opening in the conducting part. The key, at least the key is what? Open. Why closed circuit is what? This is a circuit in which there is no gap. There is no what? Gap. It is tight. The flow of electric current, it has a complete circuit. It completes the what? Circuit. When it starts from the negative terminal, it gets to the what? Positive terminal. It gets to the what? Positive terminal. Current flow out the circuit without a break in the path. Yeah, that's what we call closed circuit. So this is the diagram. This is the open circuit. I can see the closed circuit is producing what? A light. So let's look at the potential difference and the electromotive force. What is the difference between the potential difference and electromotive force? In the case of potential difference, it is the work done in moving a positive charge from one point to another. From one point to another in the what circuit? From one point to another. While electromotive force is the work done in moving a 1 coulomb of electricity in a circuit, not from one point to another. It is in the whole circuit. Are you getting what I'm saying? We all know what work done is. This is the force times perpendicular distance. That is the force, and multiplied by the what distance. So the work done in moving a charge, a positive charge, from one point to another is called the potential difference. While the work done, total work done in moving a charge throughout the circuit is the electromotive force. Let me show you the difference here. Look at the circuit very, very well. Look at the diagram very, very well. In the case of EMF here, look at the yellow sign, yellow printed diagram here. This is the what? The cell, the circuit, the complete circuit. You can see current moves from what? This terminal, and it's complete here. This is the EMF here. Around the circuit, that is the charge has flown around the circuit. While in the case of what? Potential difference, the charge has flown from the circuit, but only from this point to this point. That is where you calculate your what? Your potential difference. Only from this point to this point. So go back to the definition. The potential difference is the work done in moving a charge, a positive charge, from one point to another. And it's calculated mathematically as a work done over a charge, where W represents the work done, and it's a charge is represented by what? Q. The unit of potential difference is what? Volts, represented as what? V. While the unit of electromotive force is also measured in volts. So I would like you to do something for me. Get your pen and your book. State 5 differences between the what? Electromotive force and the voltage. State 5 differences between what? Electromotive force and voltage. This will be part of your assignment. State 5 differences between the what? Electromotive force and the potential difference. I believe you understand that. So let's go to the next topic. To the next subtopic rather, resistance. We are from the basic knowledge of conductors and insulators. You know, materials that allows the flow of electric currents. Electricity is called what? Conductors. Why those that do not allow the flow, that do not permit the flow of electric currents within them are called insulators. Materials like a wood is an insulator. It doesn't allow the flow of currents. While metals like iron is a conductor. It allows the flow of what? Electric currents. So the resistance is the degree by which a material has the capacity to resist the flow of electric currents. That's called the resistance. It is the ability of the capacity of a material to impede, to stop the flow of electric current passing through it. It's called the resistance. So let's look at the definition here. All materials possess a degree of resistance to the flow of current through them. It can therefore be defined as the repulsion of flow of current, and the unit is ohms. You can say repulsion, to repel, to stop, to go against. It's called repulsion. So the ability of the material to resist is the what? It will resist electric current is called the what? Resistance. And it is measured in what? In ohms. The unit is what? Ohms. So this is the how to represent ohms. This is ohms. That is ohms. So we'll go to Ohm's law. Repeat after me. Say Ohm's law. Say Ohm's law. This is one of the fundamentals of electricity. It's one of the fundamentals of what? Electricity. Stating Ohm's law, you say that it is the current. The current flowing through a metallic conductor. We all know a metallic conductor, that is, it allows the flow of electric current. The current flowing through a metallic conductor is directly proportional to the potential difference. We all know what potential difference is. That is the work done in moving a positive charge, a column of charge from one point to another. So it's not saying the current flowing through a metallic conductor is directly proportional. What we mean directly proportional, you know that when there's an instant increase in current, there's also an increase in what? Potential difference. That's what directly proportional means. When there's a decrease in current, there's a decrease in the potential difference. So Ohm's law is stating that the current passing through a metallic conductor is directly proportional to the potential difference across the end. provided the temperature and other physical conductors properties are kept constant. Other physical properties, conditions of the conductor are kept constant. Conductors that obey Ohm's law are called ohmic conductors, while the ones that do not obey Ohm's law are called non-ohmic conductors. They are called, this is different between what ohmic conductor and the non-ohmic conductor. Ohmic conductors obeys Ohm's law. Non-ohmic does not obey Ohm's law. They do not obey. So mathematically, that is I is representing the current, while V is the potential difference. I already told you that I is current and V is what the potential difference. This is the mathematical illustration. That is I. This is the symbol for proportionality sign, which is I directly proportional to current, where I is the current and V is the potential difference. So in breaking this out, you let me give you an illustration. Look at it here. V, I, and R. Solving mathematically, you know, when you want to convert a proportionality sign to an equal to sign, there has to be a constant, a proportionality constant. In this case, the R, the resistance, is the what? Proportionality constant. In order to convert what? The proportionality sign to what? The equal to sign. So we have a V over I equals to what? R. But you can express all these characters, all these conditions, the voltage, the current, and the resistance as the subject of the formula. You can look at here. So V equals to IR. Solving through this, you just multiply, make V the subject of formula here. And here, I, make I the subject of formula, you have this. But this is the diagram of Ohm's law. You can draw a triangle like this and separate it in three functions. You have your V, which is the voltage from the first part. You can see V equals to what? IR. This shows that V equals to what? IR. Here, I is circled, that is I equals to what? V over R. And here, R is circled, that is V over what? I. V over I. Where V is the voltage, I is the current, and R is the what? Resistance. And so with this diagram, you'll be able to understand that, okay, when we are looking for voltage, it is what? IR. When we are looking for current, it is what? V over R. When we are looking for resistance, it is what? V over what? I. You understand? So let us go to factors affecting the resistance of a conductor. Factors affecting the resistance of a what? Of a conductor. They are factors that affect the resistance of a conductor. That is the flow of the repulsion of electrical charge in a material. So these are the factors affecting it. One, we look at the length of the material. The length of the material. Look at the diagram illustration here. That is that the length of the material is directly proportional to the what? To the resistance. This is the first factor that affects what? The resistance of a material. That is, the length is directly proportional to the what? To the resistance. That is, if there's an increase in length, look at it. The length here is what? 1 length. Length is what? 1 here. And the ohms is what? 1 ohms. There's an increase here. That is, the length is increased by what? 2 lengths. And then also what? There's an increase in what? Ohms, making it 2 ohms. That is the increase in the length. We give a what? Increase in what? In the what? Resistance. This is one of the factors that affects what? The resistance of the what? Material. Number 2, the cross-sectional area. The cross-sectional area. This is inversely proportional to the what? Resistance. Unlike the length, which is directly proportional to the resistance, the cross-sectional area is inversely proportional to the what? Resistance. That is, an increase in what? Area brings about a what? A decrease in what? The resistance. Look at here, A is 1A, and the resistance here is 2 ohms. Here, A is what? 2A, and the resistance here is what? 1 ohms. That is, an increase in cross-sectional area bring about a decrease in the what? An increase in cross-sectional area bring about a decrease in the what? In the resistance. So it is inversely proportional to the what? To the cross-sectional area. Number 3 is the temperature. The higher the temperature, the higher the resistance. That is, the temperature is directly proportional to the resistance. If there's an increase in temperature, it brings about an increase in the what? Resistance also. It brings about an increase in the what? Resistance also. I hope you are following. Let me go back. The length is directly proportional to the resistance. That is, an increase in length brings about an increase in what? In resistance. Cross-sectional area is inversely proportional to it. That is, an increase in resistance brings about a decrease in the what? Cross-sectional area. While the temperature is a what? Directly proportional to it. An increase in temperature brings about what? An increase in the resistance. These are the factors affecting the resistance of the material. And we have the kind of material. What is the material made up of? Look at the example here. Iron has more electrical resistance than the geometrically similar copper conductor. That is, the kind of material depends the rate of what? The resistance. You can see iron has more resistance than what? Copper. Copper will allow more flow than what? Iron. You get what I'm saying? Iron has more electrical resistance than a geometric solar conductor. So we'll go to the next thing, which is what this is now the resistance of the wire of the metallic conductor maintained at a constant temperature is related to its length, cross-sectional area by the expression. This is how you express the resistance at a constant temperature now, whereby the resistance is what? The temperature is constant. You can express it that R is directly proportional to the length and inversely proportional to the what? Cross-sectional area. You know how to express that this R is directly proportional to length and inversely proportional to the what? To the area. We are now look at this after converting from proportionality sign to equal to sign, we have a proportionality constant. The proportionality constant here is the what? Rho. We call it rho. RHO. It's called rho, where rho is the constant of proportionality, and the name of the rho is called the what? Resistivity. It's called the what? The resistivity is the constant of proportionality. This is by which you can express the resistance. Sometimes in some questions you can be given the length, the area, and the resistivity. So you have to find the what? Resistance. This is the mathematical way by which you can calculate the resistance of a what? Of a material. The mathematical way by which you can calculate the resistance of a material. So let's go to the next thing, which is what? The resistivity. 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 This is defined as the resistance of a unit length. The resistance of a unit length, follow the formula, mathematical formula of a material of unit cross-sectional area. Resistivity is directly proportional to the what? To the resistance, and directly proportional to the area, but inversely proportional to the what? To the length. So this is the mathematical expression of what? Resistivity. The mathematical expression of what? Resistivity. And the unit of resistivity is measured in what? Ohm meter. Repeat after me. Say ohm meter. Ohm meter. That is the unit of resistivity. Let me go back again. That is resistivity is directly proportional to the what? To the cross-sectional area, and directly proportional to the resistance, and inversely proportional to the length. That is, the resistivity can be expressed as the product of the resistance and the cross-sectional area to the length of the material. To the length of the material. Resistance there is measured in ohms. Cross-sectional area is measured in meter square, while the length is measured in what? In meter. So the unit of resistivity is what? Ohm meter. So we go to the next subtopic, which is what? Conductivity. From the what? Resistivity and conductivity. Conductivity is the opposite. Is the what? Opposite. The alternate of what? Resistivity. Is the what? Opposite of what? Resistivity. And this is the degree through which conductors allow the flow of what? Current through them. The ability, the capacity of a material to allow the flow of electric current through them is called the what? Conductivity. You can see it's opposite to the what? To what we define in resistance and resistivity. This one is the ability, the capacity of a material to allow the flow of current to them is called the what? Conductivity. And it is measured in what? Siemens. It is measured in what? Siemens. The unit of conductivity is what? Siemens. You know, the unit of resistance is what? Ohms. The unit of resistivity is what? Ohm meter. But the unit of conductivity is what? Siemens. This is what? Siemens. It is also known as what? The reciprocal of resistivity. By reciprocal, we know it is the inverse, the alternate of what? Resistivity. And this is the expression that is resistivity equals to what? 1 over conductivity. In case you are given a question whereby you have the resistivity and you're asked to calculate the conductivity, this is the expression to use in calculating it. So these are their units to express the formula that is rho equals to 1 over Siemens. Rho equals to 1 over Siemens. This is what we have come to the end of the class now. So let me just recap on what we said earlier. We talked about electricity, which is the flow of electric current, and we talk about electric current, which is the rate at which electric current is flow, the rate of flow of what? Electric charge, and it is mathematically described, expressed as charge over what? Time, where electric charge is represented as Q over what? T. Q over T. And the unit of what? Electric current is what? Ampere. The unit of electric current is what? Ampere. Using the diagram to illustrate it. So we talked about electric circuits. This is a medium or path by which electron flow. And we have two types of electric circuits. We have the open circuits and the closed circuits. The open circuits, we're talking about the key, whereby the key is open, which does not allow a complete flow of what? Electric current in a circuit. There's a break in the path of what? Flow of electric current. While in the closed circuits, there is no break in the path. It allows the flow of a complete flow of electric current around the circuit. So we talk about potential difference, which is the work done in moving a column of charge from one point to another in an electric circuit. while electromotive force is the total work done in moving an electric charge in the whole circuit from one terminal to another terminal, from the positive terminal to the negative terminal in the whole circuit. So we talked about resistance, which is the repulsion of flow of electric current, the ability of a material to resist, to impede the flow of current through them, and the unit is what? Ohms. So we further went to resistivity. We further went to Ohm's law, which is states that the current passing through a metallic conductor is directly proportional to the potential difference, provided all other parameters aside temperature are constant. And this is the expression that is V equals to IR, or I equals to VR, or R equals to V over I. So factors affecting the resistance of the material, we talk about the length, which is directly proportional to the resistance. That is an increase in length, not about an increase in the what? Resistance. The cross-sectional area, which is inversely proportional to the resistance. That is an increase in the area of a material, bring about a decline in the what? Resistance. While we talk about temperature, which is directly proportional also, that is an increase in temperature brings about an increase in the what? Resistance. And the type of material used, look at it, iron has more electrical resistance than the copper conductor. So resistance is expressed as expressed as equals to resistivity, product of resistivity and the length of the material over the area. This is the mathematical expression of the resistance, where R here is the resistance, rho is the resistivity, L is the length of the material, and A is the cross-sectional area. So we look at resistivity, which is the product of resistance and the cross-sectional area to the length, and is defined as resistance of a unit length of material of cross-sectional area. And the unit of resistivity is what? Ohm meter. This is it. Ohm meter. It's represented as ohms, as rho rather. Conductivity, this is the degree by which a conductor allows the flow of current through them. The degree by which a conductor allows the flow of current through them. And the relationship between resistivity and conductivity is resistivity equals to 1 over conductivity. That is, the reciprocal of conductivity is resistivity. The reciprocal of conductivity, the inverse of conductivity gives the what? Resistivity. I really appreciate your time. We have come to the end of the class. And beforehand, I have sent your notes to your online notes. I believe you have received it. And there are some practice questions that has been set aside to flow with it. I believe with the explanation, you can solve all the questions from Ohm's law, resistivity, and conductor. I will thank you very much for your time, for your patience. And I believe as we're flowing, you have achieved what we have set aside from our learning objectives to achieve. Thank you. I'll see you in the next class.